Hello everyone, welcome back. In today's video, we are going to talk about another very important problem. I would say, uh, like this question is usually asked in a lot of online assessment or of a lot of big companies. This was asked last time. It was asked in Citadel online assessment. Um, which this question is triplets, and in this question, basically, we have to find out. We will be given an array of n distinct integer and an integer threshold. How many ABC index triplets exist that satisfy both of the following condition as shown in the picture? So for this one, we have to make sure that for that triplet index ABC, A array, the element at index A in the array has to be the A has to be smaller, B array at position C has to be greater than array at position B than array at position A. And the summation of array A, array B, and arrays at index C has to be less than equal to T. The T is going to be a value that is given in the question. So let's dive into the solution before, and also let's talk about this example as well to get a better understanding of the question. So in this question, we are going to get a parameter, two parameter, basically an array and an integer threshold. Here, and we have to output the number of triplets that we can obtain from this array, which would be less than that threshold that we have 8. So let's talk about this example in which we have an array with element 1, 2, 3, 4, and 5, and the value of t is given as 8. How many triplets we can form using this array, which would be less than equal to t, which is 8. So we can form, and we have to make sure that index has to be in an increasing order. So for this, we can make like 1, 2, 3. First of all, these three triplet, uh, which would be 1 plus 2 plus 3 is 6, which is less than 8. So we can form this 1, 2, 4, which is 7, which is less than 8. So we can form this triplet as well. 1, 2, 5, which is equals to 8. So we can form this triplet as well, or 1, 3, and 4, which is 8 as well. So we can form 4 triplet which can satisfy this constraint. So the output would be 4. Now, how to solve this question? So basically, there are multiple ways to solve this question. The brute force approach is going to be by solving this by O of n cube time complexity using 3 for loops, iterating all of them. Like we are basically checking each of the uh, element for the triplet using a for loop. Let's say we have 3 for loop I, j, and k, iterating as I, j, and k. I for the first element, j for the second element, and k for the third element. And we are checking for each I, j plus k is less than or equal to 8 or not. If that's 8, then we are going to increase the value of count by 1. So that's one approach. This is a brute force approach, but we are not going to solve using that approach. So we will try to solve this question in a time complexity less than O n cube. So we are going to find a way to solve it in, let's say, O of n square of O, or O of n log n, or even lesser if possible. So one of the solution that comes in my mind is we can solve it using O of n square using two-pointer method. So what is two-pointer method? Two-pointer method is like we are going to take we are going to point at two numbers at simultaneously. So one is going to uh, we are going to use two for loops. First is for the first element, which is I, let's say, and second for loop we are going to, in the second for loop we are going to take 2 pointers, in which we are going to point at two index at one time. using 2 pointer, and then we are going to make some operation like shift one pointer or shift the other pointer based on some operation that we are going to do. So let's straight dive into the solution. This is the thought process. So this is the thought process that we built before uh, going straight into the solution. So now this is the solution part. As given in the solution, we have been given an array of vector as an input and an integer t. So what we did, first of all, we sort out the array. We sort out the reason why we sort out the array to get that value, to get the array in a ascending order. So in this case, after sorting out the array, we are iterating the first index, which is starting from 0 to which is less than n minus 2. The reason being it's n minus 2 because the first element cannot go beyond n minus 2. Now, like I explained in the solution approach, we are going to use 2 pointer, and the two pointers are going to uh, uh, point at two index. The first index is going to be I plus 1, which is start of the second element. Because if the first element is starting from I, the second element can start from at best I plus 1. And the last element, which is the third element, we are going to start that value from n minus 1, which is last element of the array or vector, which is end of the complete array, because that's the maximum that we can go for the third element. So this is the 2 points where we two pointer that we are going to start our iteration from. Now this while loop, basically what this while loop is checking, we are basically checking the ith element, then j and k. J is the first element of the remaining array that we have after I, and k is the last element of that remaining array. And because this is sorted out initially in ascending order, that's why we have an increasing value. So the k is pointing at an index at k is pointing at that index of the array which is maximum, and j is minimum. So when we are summing up the for each, well, we are summing up the value of array of I plus j plus k, we are checking if that value is less than t or not. If that value is less than t, less than or equal to t, in that case, all the element that we have inside that remaining array, all of the array can form a triplet which would be less than equal to j. Because, and let me explain you the reason why. If we take the last as the maximum, then and the first as the minimum value of the remaining string, then for all of the value which the number of array that we can found is, if we are going to shift leftward from the extreme from the extreme value of the k, then we are going to get this the value of sum as less than the that we had initially. The sum is going to get reduced because this, now we are decreasing the value of k, array of k, because this is in decreasing order and we are going leftward, so we are going to decrease the value of array at k value because we are going rightward. So all that we can form k minus j elements in short. The number of, so we don't have to check for all of the element one by one again, because these values are sorted in array orders, ascending order. So we can directly increase the value of count by k minus j. So these are the number of triplet that we can form if that value is less than equal to k. In that case, first of all, we will count all the values. Now we are going to increase the value of j by 1 by right side, and we will keep the value of k as it is, like the place where it was initially, like the maximum value. And we are going to check again that if statement. Again, if that if statement is less than equal to t, then again all the elements that are present inside that element can form a triplet. So this is how the first if element works. Else statement now. if that some value is greater than t. In that case, else statement is going to get run. When else statement is operating, like in that case, we are decreasing the value of third pointer towards left. Why we are doing this? Let me explain. Now, this when the value of summation of value, which is array of I plus array of j plus array of k, is more than t. It means we have already we have got this value of summation which is greater than t. In that case, we have to reduce our sum, reduce the summation of array, and we can only reduce it by reducing the maximum value of the summation, which is k. Right now, the maximum value that we have k among the triplets is the array of the array value which is present at the kth index. So we have to reduce that value and we have to find the summation again, and we have to check it. Like we have to basically discard that element right now because the summation is more. So we have to reduce our sum value and we have to check again whether that value is less than equal to k, less than equal to t or not. So that's why and we are not going to increase the value of count this time because we are only going to increase the value of count when we got a sum which is less than equal to t. So in this case, we are just going to decrease the value of k by k minus 1, which is k minus minus as shown in the code. And then we are going to iterate this while loop until and unless the value of k is greater than j. Because k is basically the third pointer, so it will be this loop will only we can only run this loop until and unless we have the value of k as greater than j, because the third element is going to be after a second element at all times. And finally, we are going to return the value of count that we got from this function. So this is how this function code runs. This is pretty much straightforward, I guess. So uh, I would like to uh, finish this video, and I would like to say if you found this video helpful, and don't forget to like, subscribe, and drop any comment that you have or your thoughts or your questions. Keep coding, guys. I'll see you in the next video. Thank you.